In the next video, we're going to be solving quadratic equations. And if you don't remember what a quadratic equation is any equation that has a square in it. If you were to take away the square, we deal with what we dealt with in the last video. It would be a linear equation then, because it's y to the first. However, anytime that you have that square in here, we have these different methods. And that's what we're going to go over with this lesson, all the different methods. First one being the method of factoring, which is hands down, in my opinion, the best way of solving these. If they're factorable, okay, on the left side, first off, this has to be set equal to 0. The left side, we're going to factor. We're going to ask ourselves, let me zoom in, y times y gives me y squared, and what adds to give you this, multiplies to give you this, would be a negative 15 and a positive 2. Since two things multiply to give you 0, we split them. That means that either y minus 15 is 0 or y plus 2 has to be 0. Because again, how can you multiply two things together to get 0 without one of them being 0? Solve each of them and you're finished. Either y is 15 or y is negative 2. Next one. Again, it has to equal 0. So if you have something on the other side, move it over. 2x squared plus 6x, move it over to the left by doing minus 80. Another word of advice, if there's a greatest common factor, pull it out first. So you have a 2 present in every one of these terms. So we're going to 2 parentheses x squared plus 3x minus 40 is equal to 0. Factor the parentheses, gives you x and x, multiplies to give you 40, adds to give you 3, would be a positive 8 and a negative 5. Set every term equal to 0, including the 2. However, we all know that 2 equals 0 has no solution. There's no way for that to be true. So we get answers of negative 8 and a positive 5. That's your two solutions. Number 3. Again, we need it set equal to 0, so let's move this over. You have 4w squared plus 10w equals 0. You don't have a c term here, so all you got to do to factor this is pull out a GCF. 4 and 10, there's a 2 in common. W squared and w take the lowest power. 2w times 2w plus 5 gives you that. Set each factor equal to 0. Solve gives you divide by 2, w is either 0, or subtract 5 and divide by 2, and you'd get negative 5 halves. There's your two answers. Number 4, everything has to be on the same side. So 5p squared, let's move our p over by subtracting, move the 4 over also by subtracting. This is quadratic, but it has a number out front. So this is our slip and slide or bottoms up method. To factor these, let's move our 5 to the end. I'm going to factor it over here. P squared minus p minus 20. Factor as usual. P and p, that'd be a negative 5 and a positive 4. Adds to give you negative 1, multiplies to give you negative 20. Whatever number you slipped, we now divide by. And that gives you p minus 1 in the first set of parentheses. If it will not divide, slide it back to the front. If it won't reduce either, that'd be 5p plus 4. And then solve. Set each equal to 0. We'll give you p equals 1 and p equals negative 4/5. Now, again, word of advice, you can actually, instead of, if you're using the slip and slide method, you can actually, instead of sliding it back to the front, you can, if you're solving an equation, you can just solve it from here. P plus 4/5, move it over, will give you this negative 4/5 instead of finishing out the slip and slide. Okay, solving by square roots. Now, if this is the case, anytime you're missing your b term, notice that there's a d squared but no d. There's an m squared but no m. There's an x squared but no x. This is going to be the easiest way for these type of equations. It says solve each by taking the square root. Write all irrational and complex answers in simplest form. So here's what you do. Just get d squared by itself. Move the 81 over. So you have 16 d squared equals positive 81. Divide by the 16. You get d squared is 81 over 16. Now all we have to do is take square root. So if d squared is equal to that, that would mean that d is equal to plus and minus the square root of 81 over 16. When you're taking the square root of a fraction, you can split it into the square root of the top, which is 9, and the square root of the bottom, which is 4. And there's your two answers. Move your negative 6 over, it gives you m squared is negative 8. So therefore, m is equal to plus and minus, never forget the plus and minus, square root of negative 8. Now we just finished with talking about i's, so this is going to be an I answer. So that would be plus and minus. We got to split that into root negative 1 times root 8. And then root 8 we can actually split again into root 4 times root 2. So this is going to be 2i root 2. There's your two answers. Number 7. Move the 11 first. So you have 3 halves x squared equals, subtract 11 gives you 48. To get rid of the 3 halves, come to the other side to divide by 3 halves. So you flip and multiply. Cross cancel leaves you with a 1 and a 16. So that gives you x squared is 32. Therefore, x is equal to plus and minus the square root of 32, which is plus and minus root 16 times root 2, which is plus and minus 4 root 2. Okay, number 8. Step number 1, let's move our 10 over. Leaves you a negative 7s squared equal, when you subtract 10, 1 minus 10 is a negative 9. We now divide by negative 7, and it gives you s squared is equal to a negative divided by negative is a positive, so that'd be 9/7. To get rid of a square, let's do plus and minus the square root of 9/7. Now we do want to rationalize that. We don't want to leave that radical 7 on bottom. So, and the top I know the square root of, so we can do plus and minus the square root of 9 over the square root of 7. Square root of 9 is 3. So let's rationalize by multiplying top and bottom by root 7. So that would be plus and minus. On top you now have 3 root 7. On bottom, root 7 times itself would be plain 7. Okay, next step, let's solve by completing the square. And again, the way that I complete the square might be a little bit different from these steps. You can look at them if you'd like, but let's just jump into the problems because, again, sometimes I work my completing the squares a little bit different. Okay, here's my steps. Step number 1, always move my plus 20 over, which I believe is different from their steps. So y squared plus 12y equals negative 20. Step number 2, if there is a number out front, it has to be factored. Since it's 1 here, we're fine. Now we're going to complete the square. If you don't remember how to complete the square, this 12, you always take half of it and then you square it. And you get a positive 36. Whatever you get, you add to both sides. And that's to keep it legal. You can't just add something to one side without doing it to both sides. And that would be your addition property of equality. It is legal once you add it to both sides. As soon as you complete the square, now this should be, if done correctly, a perfect square, so we're going to factor it. Now I'm going to show you with 2 sets of parentheses to begin with, but you really don't need 2 sets. Because when you say what adds to give you 12, multiplies to give you 36, it should be the same value. That's what we mean by completing the square. So I can just write this as y plus 6 squared. Equals, the right side is negative 20 plus 36, which is 16. Now this is the whole purpose of why we did that. To get rid of a square, we're going to square root. So y plus 6 is equal to plus and minus the square root of 16. Move the 6 over, gives you y equals, and I like to write it first, negative 6 plus and minus 4, and that's going to be your two answers. Y equals negative 6 plus 4, which is negative 2. Y equals negative 6 minus 4, which is negative 10. Let's do another one. Step number 1, again, I like to move my 25 over. It gives me 7b squared plus 14b equals, when you add 25, it gives you a 21. Now on this one, I noticed something that would make this problem, it's going to make this problem a whole lot easier. All 3 of these terms are divisible by 7. So if possible, so that we don't have to factor, let's reduce this thing. So equals 3. And that simplifies our problem so much. Because that's 7 out front, when you have to factor that, that's what makes these a little bit harder. Okay, complete the square. To complete it, take this b term, take half of it, and multiply it times itself, and gives you a positive 1. Half of it's 1, 1 times 1 is 1. Add that to both sides. As soon as you complete the square, we always factor. Instead of two sets of parentheses, I'm confident that it's going to multiply into or factor into something times itself. B times B. What adds give you 2, multiplies give you 1 will be a positive 1 and a positive 1, so we are right. The right side is 3 plus 1, which is 4. We now get rid of the square by square rooting, so you have b plus 1 equals plus and minus the square root of 4, which we know is 2. Move the 1 over and you get b is equal to negative 1 plus and minus 2, which are your two answers. B equals negative 1 plus 2, which is 1, and b equals negative 1 minus 2, which is negative 3. Number 11. Step number 1, move the 8 over. Gives you v squared minus 13v. When you subtract 8, it gives you a negative 12. Complete your square. We got to take half of this. Now that's a problem. We're starting into the tougher ones now. Here's how I want you to work this. When you take half of negative 13, I want you to divide it by 2. That's how you take half of something, but leave it like that. Then you've got to square it. The reason I left it like that is because it's easy to square fractions. Negative times negative is a positive, and you simply square the top and square the bottom. 169 over 4. That's what you're going to add to both sides. Positive 169 over 4 and a positive 169 over 4. When you go to factor this, it has to be a perfect square, v times v, but that other term, that's going to be a problem. But here's the easy way of doing it. You're looking for what adds to give you this. Wait a minute. Didn't we just half it? And won't it always be half of that is what's going to add to itself to give you the negative 13? What about multiplies to give you this? Well, didn't we just do negative 13 halves times negative 13 halves to give me that value? So it's always going to factor into half of this term. So minus 13 halves. This right here is always going to be the second part of your factor. Equals negative 12 over 1. We need a common denominator. Multiply top and bottom by 4. That'll be a 48 on top. So that gives you 121 over 4. That worked out nice and neat. To get rid of a square, we square root. So that'd be plus and minus the square root of 121 over the square root of 4. Move your 13 halves over. Gives you v equals positive 13 halves plus and minus 11 halves. So there's your two answers. V is equal to 13 plus 11, which is 24 halves, or 13 minus 11, which is 2 halves, which would be 1. So your two answers are 12 and 1. Okay, number 12. See the number out front, which makes me pretty certain that we're going to have to factor on this one since we haven't yet. Let's move our plus 44 over. It gives me 4a squared minus 20a equals a negative 49. I think this one might be a pretty ugly problem because we're going to be dealing with some imaginaries here as well. Next step, again, if there's a number out front, it must be factored out. So we have a squared minus 5a left inside parentheses. They gave us one where we have an odd number again as well. So pretty much this is as hard as these problems can get. So next step, we're going to complete our square. And to complete our square, we always again take this term, negative 5, we half it, which again, I would rather you leave it as a fraction, which makes this so much easier because now to square a fraction, you simply have to do a negative times a negative is a positive, square the top and square the bottom. So we're going to add 25 fourths to both sides. However, you've got to be careful because you didn't just add 25 fourths to this left side. Since you factored, anytime you factor, you have to keep this in consideration. You added 4 times 25 fourths to this side. So in order to figure out what you're going to add to the other side, anytime that you're dealing with one that you're factoring on, multiply that back out. So you added 4 times 25 fourths, which is a positive 25 to the left side. So that is what you have to add to the right side, not the 25 fourths. Multiply it back out to see what to add to the other side. So we always factor next. Now I'm confident this is a perfect square. So it's going to be a times a gives you a squared. What adds to give you this, multiplies to give you this will always be half of this, which would be negative 5 halves. That always completes your factoring. And on the right side, a negative 49 and a positive 25 is a negative 24. Next step, we're going to get rid of the 4 by dividing, which gives us a minus 5 halves squared equals negative 6. To get rid of a square, we do plus and minus the square root. A minus 5 halves equals plus and minus the square root of negative 6. Now I'm going to write that as the square root of negative 1 times the square root of 6, which will be I root 6. Next step, we got to move the 5 halves back over. So we have A equals 5 halves plus and minus I root 6, which is one way to leave your answer. Another way to leave your answer, since we're about to do the quadratic formula, this is what your answer would look like had you used that formula. You can find a common denominator. You can multiply top and bottom here by 2, and that'd be A equals 5 halves plus and minus 2I root 6 over 2. And that would equal, A is, we have our common denominator of 2 now, that'd be 5 plus and minus 2I root 6 all over 2. So either one of those answers will be fine. Okay, our last method for solving quadratic equations by using the quadratic formula. So here is your quadratic formula, negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. And then all we're going to be doing is plugging in our a, b's, and c's. A squared plus bx plus, or ax squared plus bx plus c equals 0. That's what all quadratic equations look like. So we're going to take our a, which is in front of x squared, our b in front of x, and our constant term c, plug it into this formula, and clean it up. That's it. So in number 13, this is not in standard form. It does have to equal 0, so we're going to move our 10k over. It gives me negative k squared, a negative 10k, and a negative 8, and now I can very easily identify the a, which is negative 1, the b, which is negative 10, and the c, which is negative 8. Now, one thing I do like to do is I always like to do the stuff under the radical first. B squared minus 4ac. Let's come over to the side, and I like to plug my a, b, and c into that first because, again, that's under the radical in my formula. It's called the discriminant. It tells you what kind of answers you're going to have, if you're even going to have a real answer. So let's do that first. So b, which is negative 10 to the second power, is 100. Minus, I always like to bring this down, the minus down. We have to do 4 times a times c. That's 4 times negative 1 times negative 8. That'd be negative 1 times negative 8 is 8. 4 times 8 is 32. So 100 minus 32, my discriminant is equal to 68. And again, that's the stuff that's going to be under my radical. So if you would like to, I like to go ahead and let's simplify our radical so we don't have to put it in our formula till it's completely simplified. Split it into root 4 and root 17. That'll be 2 root 17. Now let's go back to our formula and look how easy it is now. X is equal to negative b, which would be negative negative 10, which is 10, plus and minus the square root of b squared minus 4ac. We're done with every bit of that. That's 2 root 17, all divided by 2 times a. A is negative 1, so that'd be negative 2. So now let's clean it up a little bit. Let's use our distributive property. 10 divided by negative 2 would be x equals negative 5. Now, when you divide a plus and minus, a positive negative by a negative, you're going to get still a positive negative. So you really don't have to switch those signs because both signs are there anyway. 2 divided by 2 cancels and leaves you with root 17. There's your two answers, negative 5 plus root 17 and negative 5 minus root 17. Those are both irrational answers. The next one. First thing I notice is 6, 3, and 9 are all divisible by 3. So let's go ahead and do 2x squared equals x minus 3 to simplify our problem down just a little bit. Move everything to the same side. 2x squared minus x plus 3 equals 0. You see a is 2, b is negative 1, c is 3. Again, I like to do b squared minus 4ac first. B to the second power would be 1 minus 4 times a times c. Let's go ahead and do 4 times a times c. 4 times 2 times 3. That'll be 24. So you get a negative 23. And again, that's the stuff under your radical in that problem. Since the stuff under your radical is going to be a negative value, you already know that your answer is going to be a complex or imaginary answer. So if you'd like to go ahead and put that under the radical, clean it up. That's the square root of negative 1 times the square root of 23, which is I root 23. And now let's plug it into the rest of our formula. Again, the formula was x equals negative b plus and minus the square root of stuff over 2a, and that's b squared minus 4ac. So your final answer, x equals negative b, which would be 1, plus and minus this stuff, which we've already cleaned up, I root 23, all divided by 2 times a is 2, so that'd be a 4. You can leave your answer like that. You could split it if you would like and do 1 over 4 plus and minus I root 23 over 4. Either one of those answers are fine. This is the way that you're going to see it left most of the time. Okay, number 15, we're talking about projectile motion. We're launching rockets here. It says a rocket is launched upward with an initial speed. There's your speed. That's how fast it's going to begin with. Its path is modeled by this equation to where h is the height and t would be the time after launch. Time is in seconds. How long does it take for the rocket to reach the ground? So it's shot upward, and then it's coming back down after it runs out of propulsion. We want to know how long it takes for it to hit the ground. Here's the key to that. When it hits the ground, height will be 0. So pretty much you're just taking this equation, negative 16 t squared plus 325t, and you're setting h equal to 0. Now, out of all the methods that we've done, which one would be the best here? Definitely would be factoring because you have no c term. So why not just take this, factor out a t. You're left with a negative 16t plus 325. Set each factor equal to 0, and that tells you. You get set the first factor equal to 0. You get 0. Set the second factor equal to 0 plus 325. It looks weird with that t next to the plus, equals 0. Subtract 325, divide by negative 16, and there you'll get t is equal to 20.3. So why are there two different answers? Because we asked, when will the height be 0? When you began, the height was 0, and then after the launch, the height was 0 when it hit the ground again. So here's where it began. And here was after 20.3 seconds, it'll hit the ground again.